Okay, so we're going to talk about lines and transversals. And so first thing we need to do is define a transversal. A transversal is a line that intersects two or more lines. So when we have two or more lines present, we call it a system. So a transversal is a line that intersects two or more lines. So just like this picture here, my transversal would be this line right here. It's intersecting two lines. If we have more than two lines being intersected by a transversal, we get interior and exterior angles. Interior angles are between the lines that are being intersected, and the exterior angles are the ones outside of those lines that are being intersected by the transversal. My exterior, I highlighted in pink. My interior, I highlighted in green. And so we'll list those out. So interior angles would be angle 3, angle 4, angle 5, and angle 6. My exterior angles would be angle 1, angle 2, angle 7, and angle 8. When we have a system of lines, we have some angle relationships between those angles. So if we look down here, we have some angle relationships. So corresponding angles are angles that are formed in matching corners. So some of my corresponding angles would be angle 1 and angle 5, angle 4 and angle 8, angle 2 and angle 6, and angle 3 and angle 7. So that means they are both in the same spot. They're both on the same side of the transversal. So like 1 and 5 are both on the left side of the transversal. They are both above the lines that the transversal intersects. So 1 and 5 are in the same spot. Second relationship is a same side interior angle relationship. So that means they are on the same side of the transversal and they're on the interior of the system of lines. So that would be angle 4 and angle 5, and angle 3 and angle 6. Same side exterior, so same side is telling me the relationship to the transversal, exterior is telling me the relationship to the other line. So same side of the transversal, and they're outside. So that would be angle 1 and angle 8, and also angle 2 and angle 7. So those are same side transversal, alternate interior and alternate exterior. Alternate means opposite sides of the transversal and they're inside. So that would be angle 4 and angle 6, and 3 and angle 5. Alternate exterior, opposite sides of the transversal, and on the exterior of the system of lines. So that would be angle 1 and angle 7, and angle 2 and angle 8. And then lastly, vertical angles. We've already talked about this when we briefly talked about angles, but those are the ones that have the common vertex. Even in a system of lines, we still have vertical angles. We also have linear pairs. So some of our vertical angles, we've got angle 1 and angle 3, angle 2 and angle 4, angle 5 and angle 7, and we also have angle 6 and angle 8. So if the system of lines, so if these two lines right here had been parallel, those angles, those corresponding angles, same side interior, same side exterior, alternate interior, alternate exterior, and vertical angles, have a relationship. So with corresponding angles, they are, if two parallel lines are cut by a transversal, then each pair of corresponding angles are congruent. So we can say that angle 1 is congruent to angle 5. We can also say that angle 3 is congruent to angle 7. So instead of saying that they are corresponding angles, if those lines are parallel, we can say that they're congruent. We can also say angle 2 is congruent to angle 6. and angle 3 is congruent to angle 7. So those angles that are in the same spot, that have the same relationship to the transversal and the parallel lines, they're congruent. Alternate interior angles, if two parallel lines are cut by a transversal and they create pairs of alternate interior angles, we say that those alternate interior angles are congruent. So we would say angle 3 is congruent to angle 6 and angle 4 is congruent to angle 5. Alternate exterior angles, if they are formed by parallel lines being cut by a transversal, they have the same relationship as alternate interior angles. So we would say angle 1 is congruent to angle 8. And we would say angle 2 is congruent to angle 7. Same side interior and same side exterior are supplementary, or they equal 180. So here we would say angle 3 plus angle 5 equals 180. And we would say angle 4 and angle 6 equal 180. Then those same side exterior, we would say angle 1 and angle 7 equal 180, and angle 2 and angle 8 equal 180. So we've got two relationships. We either have congruent angles or supplementary angles. So from the first day we talked about angles, we know that vertical angles are congruent. And we know that linear pairs are supplementary. And then if we break it down, if we have parallel lines cut by a transversal, we know that alternate interior are congruent. We know that alternate exterior are congruent. And we know that corresponding angles are congruent. So this table right here is going to be really helpful. And then our supplementary angles, or if they equal 180, we've got those linear pairs. We also have same side interior and same side exterior. To help you remember your same side, go with supplementary. Everything else is congruent. So in example 1, we're told that the measure of angle 5 is 68 degrees. Find the measure of every other angle. So if we start with 68 degrees, we can start by using what we know about vertical angles. We can start by using what we know about linear pairs. We can use alternate interior, alternate exterior corresponding. We can use any of the ones that we know. And so there's lots of different ways to fill this in. I like to start with my vertical angles. So if angle 5 is 68, I know that its vertical angle 2 is also 68. Alternate interior angles tells me that 2 and 7 are the same. So 7 is 68. And then I've got that vertical angle relationship again with angle 4. We can also check ourselves. So angle 5 and angle 7 are corresponding. Corresponding angles are congruent. Angle 5 and angle 4 are alternate exterior, so those two are congruent. So we can kind of check ourselves with a lot of the different angle relationships. To figure out angle 1, 6, 3, and 8, we have to use some sort of relationship to find out that missing piece. So I personally see a linear pair first. I see that angle 1 and angle 5 make a linear pair. So what added to 68 gives me 180? Well, 180 minus 68 is 112. Angle 1 and angle 6 are vertical. 6 and 3 are alternate interior, and 3 and 8 are vertical. 1 and 8 are alternate exterior, congruent. However you want to see it will work. Example 2, I have my parallel lines M and N, and I have two transversals. So when we're solving something like this, we want to look one transversal at a time. So angle 2 is 92 degrees, and angle 12 was 74 degrees. So if I'm looking at it one transversal at a time, I'm going to cover up all this information with my finger and just work at 92 degrees. So the angles that share the transversal are the ones that have the relationship. So if angle 2 is 92, I know that angle 8 is 92 because they're vertical. 8 and 10 are alternate interior, so they're congruent. 10 and 16 are vertical. 1 and 2 is a linear pair, so I subtract 92 from 180, and so I get 88. Angle 1 and angle 7 are vertical. 7 and 9 are alternate interior. 9 and 15 are vertical. So now if I look at my other transversal, I know that angle 12 is 74. So that means angle 14 is 74 because they're vertical. 12 and 6 are alternate interior, and 6 and 4 are vertical. 4 and 14 are alternate exterior, so they're the same. 12 and 4 are corresponding, so they're the same. And then I see that 12 and 13 is a linear pair. So I'm going to again subtract 74 from 180 and find that whatever's missing is 106. And then all of those others have a relationship with that 106. It's very important to look one transversal at a time. All right. Last things we're going to look at is we're going to name the special angle pair and then we're going to solve for x. For the purpose of this video, we're going to set up the equation, but we're not going to solve the equations. All right, so in A, the places where I have the equations, I see that they are on opposite sides of the transversal, so bottom left, top right. They are on the interior. So if I box in my parallel lines, I see that those are the interior. So those are alternate interior angles. Alternate interior angles are congruent. So my equation is going to be 14x plus 4 equals 15x minus 5. And then you would solve for x. B, this 2x plus 62 is this angle right here. Kind of overblends. We actually have a transversal here and we have a transversal here. The only other thing I know besides that 2x plus 62 is this box over here. And we know that that is 90 degrees because it's right angle. So I'm looking at a relationship between 90 degrees and 2x plus 6. Well, if this is my transversal and the interior of my parallel lines, I don't have any information there, I know that they are on the same side of the transversal, they're both above it, and I know they're outside my parallel lines. So those would be same side exterior. We know that same side exterior angles are supplementary, so we would have 2x plus 62 plus 90 equals 180. And again, you would solve it. Over here, we have 26x plus 1 and 9 plus x. If I kind of shade in my parallel lines, I see that they're both on the interior, so now I have to decide if they are on the same side or opposite sides. They are both to the left of the transversal, so that means that they are same side interior. Same side interior angles are supplementary, so I'm going to add both of those equations together and set them equal to 180. In D, if I shade in my parallel lines, I see that my expressions, those mathematical expressions, are outside where I've shaded. So I've got some exterior angles. 21x plus 1 is on the right side of the transversal. Negative 3 plus 22x is on the left side, so they are opposite. So I've got alternate exterior angles. Those angles are congruent, and so I'll have 21x plus 1 equal to negative 3 plus 22x, and then of course I would solve for x. In E, we have an extra transversal here. We've got a transversal here. These two expressions, mathematical expressions, are sharing this transversal. So if I look at my parallel lines, if I shade between them, that would be my interior. One is on the interior, one is on the exterior. So it can't be an angle relationship where it relies on being inside or outside the parallel lines. So that only leaves me with vertical angles, a linear pair, or corresponding angles. They're not vertical, they don't share a vertex, and they're not a linear pair because they're not adjacent. So that only leaves corresponding. Well, corresponding does actually make sense because they are both on the right of the transversal and they're both below the parallel lines. So they're in the same spot. Since they are corresponding angles, I know that they are equal, and so I'll set 13x minus 7 equal to 12x plus 2. Last example in this section, we find that we have parallel lines here. If I shade them in, we've got one that is inside and one that is outside. So again, we've narrowed it down to corresponding linear pair or vertical angles. They don't share a vertex, so they're not vertical. They aren't adjacent, so they're not a linear pair. And so corresponding, one is above the transversal, one is below. So they actually don't have a relationship initially, which means I'm going to have to move my information around so that I can see what their relationship is. So if this angle is 62, I like to use my interior angle. So this angle here would be 62 degrees. I've also got some vertical angles. Either way, here I create a linear pair, which is 180. Here I create same side interior, which is 180. So either way, I'm going to add them together and set them equal to 180. So this one actually has multiple answers. So we could say linear pair. We could say same side interior. But we used a lot of relationships to solve for that one. Last couple things is when we're solving for more than one variable. So in example 4, it says to find x. In order to find x, we might have to figure out y and figure out the relationship between these y expressions and this x expression. We've got 3 sets of parallel lines, so they're all parallel to each other. So we'll go ahead and see if we can fill in some information. So 3y is a vertical angle here. That's initially what I see first, so I'll go ahead and fill it in. Then I see that 5y minus 4 and 3y are both on the interior of these first 2 parallel lines. Well, since they're both above the transversal, they're same side interior, and so I can solve for y by setting those equal to 180. We are going to go ahead and solve this one so we can find x. So combine like terms. And then solving for y, we'll have 184 divided by 8, and that means that y is 23. If y is 23, I'm going to go ahead and plug it in so I can find my other values. We find that 3 times 23 is 69. And then 5 times 23 minus 4 gives me 111. I could have also subtracted that 69 from 180. And then I now see that with these parallel lines, my 3y or my 69 angle is a corresponding angle to 2x plus 13. So now I can solve for x by setting 69 equal to 2x plus 13. And find that x is 28. And we fully answer the question. In example 5, the measure of angle 1 is 3x plus 40. The measure of angle 2 is 2y minus 20. And the measure of angle 3 is 2x plus 70. Find x and y. So in this case, my 2 angles that have an x are the ones that are going to have the relationship. So they're both above the set of parallel lines, and they're both to the right of the transversal, which means they're corresponding angles, which means that they are equal. So we'll solve for x there. Move the 2x over to the other side. Subtract 40 from both sides, and we find that x is 30. Once we have our x value, we can plug it in to solve for the angle measure of both angle 3 and angle 1. So we'll have 2 times 30, which is 60, plus 70 gives me 130. And because we know they're corresponding, we should be able to assume that angle 1 is also 130. But we'll plug it in just to make sure. So 3 times 30 is 90, 90 plus 40 is 130. So we are correct there. And then we've got to figure out that relationship with angle 2. So I see that angle 1 and angle 2 share the same transversal. I see that they're both on the exterior, and I see that they are on opposite sides of the transversal. So we see alternate exterior angles. So we actually have 2 sets of parallel lines here. And so some of the parallel lines actually act as a transversal. So it's kind of funny to see that way, but we can do it anyways. So we know that 130 equals 2y minus 20, and we'll solve for y. So we'll add 20 to both sides, divide both sides by 2, and find that y is 75. Now we don't have to find the measure of angle 2, all we had to do was find y. The last one. So in example 6, we actually have a triangle, but it has some parallel lines. With those parallel lines, we can actually see that one side of the triangle is acting as a transversal. So I like to draw it out just a little bit so it looks like the other ones that we've seen. So essentially, it looks like that. So we see that we have a 5x minus 5 and a 4x plus 10. So since we have the same variable in those equations, we need to check their angle relationship first. So they're both to the right of the transversal. They're both above the parallel lines. So they're in the same spot. So we've got some corresponding angles. Corresponding angles are congruent. So we'll have 5x minus 5 equal to 4x plus 10. And we'll solve for x. So we'll subtract 4x from both sides, add 5, and we find that x is 15. In order to figure out the y value, I've got to plug in that x value into those equations. So we'll have 5 times 15 minus 5, and we find it 70. It should be the same down here, but we want to make sure, so we'll plug it in. So 4 times 15 is 60, plus 10 is 70. And we've got to figure out the relationship between that 70-degree angle and this 6y minus 4 angle. So we can see here that we've got a linear pair. So they're supplementary. And we can also see that 4x plus 10, that 70-degree angle, and the 6y minus 4 are same side interior. Also supplementary. So we'll have 70 plus 6y minus 4 equals 180. Subtract 70, add 4, and divide both sides by 6. And we find that y is 19.